Hi guys, today I'm going to show you how to design a vision transformer model for classification and segmentation problem. So here you can see the architecture of the vision transformer. It's little different from the normal CNN method. Here you can see initially we have taken the input image and divided into patches. Then those patches are linearly projected and flattened those patches and positional or embedded. Then those tokens are given to the transformer encoder. So inside the transformer encoder we can have the multi-head attention and the MLP. So this transformer tokens are given to the MLP or classification get head. Finally we'll be getting the different kind of classes. So today I'm going to show you OCT based classification and segmentation using the vision transformer. So I will show the program. So here we can just install the Kaggle, and we have to download the images from the Kaggle, that one. So this is the image, retinal OCT images. I'm going to classify the OCT retinal images. So inside this folder you can see there are nearly 7 classes: AMD, DME, ERM, normal, RAO, RVO, and VAD. These are the classes that we are going to classify today. So then we can unzip that file. So after that we need to split the total database into training, validation, and testing. This is the program for that one. So we divided 0 0.7, 0 0.15 and 0 0.15 training, validation, and testing. So automatically we'll create one more folder. There we can see all the training and validation and testing folders here. So once completed, we can load our training data as well as validation data as well as the testing data here. So we loaded all the data. Now we want to design the vision transformer model. Before that, we can able to plot some of the images. Here what kind, normal image, DM image, like that. Now we are going to design the transformer model. So this is the next step. So initially we need to divide the images into patches. For that we need to define those functions, and then patch encoder encoder we need to design here. And then we can define our VAT classifier. So we can divide the images into patches, and patch we can encode that one, and we can apply the normalization, and then we can apply the transformer encoder, which is the multi-head attention, and finally we can use the layer normalization as well as the dense layer, and finally we can feed it to the MLP for the classification head. Here you can put it like that. So then finally we need to uh, mm, combine all the inputs and output models. Also, once we design that one, we can give the shape of our input, number of classes, and we can recall that function, and we can able to compile that one. Then we can train it here. So here we can feed our training data and validation data, number of epochs. So now we have designed this model as it is in the original VAT vision transformer. And then now we are going to train this model. So once we load the data, we can able to train this model. Now I have given the number of epoch as 20. I have already trained this model. Now so we can able to get the accuracy loss, validation accuracy, as well as the validation loss. So once the model has been trained, we can able to plot the training progress and validation accuracy and loss. After that we can able to display the confusion matrix as well as, and we can able to predict. We can give the original none of the images from the data set, and it will predict it as whether it is a AMT or normal or DME. So just I will run this one. So this is a simple one. I already ran this program. Again I'm running this once again from the training section. So this is the vision transformer core part. So I'll just run this program now. So here we can, it started to run. uh, the first epoch is going on. So in the meantime, now we have seen how to do the classification for multi-classes. Now in the meantime, I will tell you how to do the segmentation with the same kind of ViT transformer, vision transformer model. So for that, we have to same like, so here we are I'm going to show you a segmentation of the brain tumors here. So we can download the data set from there, brain tumor segmentation from the Kaggle. We can download it from the Kaggle, then we can unzip it. So once we unzip it, we'll be getting the images and the mask separately. So as like the classification only, we need to load all the images and mask separately. And here we'll be getting the image files as well as the mask file. And we can set up the training data set as well as the validation data set. So here we need to set up the CNN backbone for the ViT model. So we can able to create the CNN backbone using the ResNet 50. Then we can finally we can reshape for our pixel wise classification model. So here we can define the CNN backbone. After that, as like the classification only, we need to create the patches, then a patch encoder, and then finally the vision transformer. So here we can feed the input image to the CNN backbone, then divide it into patches and encoding, then multi-head attention, then finally given it to the MLP for the pixel-based segmentation. So here once we design the model, we can able to compile the model here, and we can able to train the model also. So in the meantime, we'll see there what's happening for the classification, whether it is completed or not. Yeah, now it's completed. Now I am running these training plots, and we can able to see the confusion matrix as well. And then we can able to test our data. So I have taken the AMD image from the AMD 104. So I have given that data. Now we can see the result, how it's coming. So I have given the AMD data, it is showing me as a AMD. So this is the classification. So now we got the accurate classification result for the OCT based classification using the ViT model. So if you want to change anything inside the model, we can able to change the attention layer. Here we can use the channel attention, combined attention, or hybrid attention, anything to improve the model performance. So this is how we can design a classification model using the ViT. Now we are moving to the segmentation part. We loaded the model here. As here I will just download those data set from the Kaggle. Now the data are downloading. So once downloaded, we can able to unzip it here, so that we will be getting the images as well as and the mask folder separately. So now I'm going to unzip it, so we can able to get the images. So there you can see the images here as well as the mask. You can able to get the mask as well. Here you can see the mask and cursor. Here you can see this is the area where the tumor is affected. And now once we get the mask, we can load the images and mask here. And now the model has been compiled and trained. Now it's going for training. It started with the epoch 1, and now the training is going on. Once the training is completed, we can able to test with our input data. There we can able to identify or segment the tumor area from the original image. So this is the result. You can see it here. So I have given the input image, this one, and I got the predicted segmented mask. As actually it's not more accurate, so we need to tune this model to get the more accurate result. So as because we have taken the backbone is the old model, that is the ResNet model, which is very old, so we need to use the recent models like efficient net or dense net or mobile net. So those kind of things will improve the segmentation accuracy as well. Now the training has been started, so it is little slow, I think, as we have more images, as well as the efficient transformer is a complex thing one, so there will be a lot of processing will be there, so it is taking time to uh, training. So anyway, we'll wait this one, no issue. So finally, once completed, we can able to check how the performance, how it's segmenting the tumor area from the brain images. Yes, the training has been completed. Now we can able to test with our data. So I have given the single image from 100.png from the data set. So I'm checking this one. So we'll see how it's working. So now it's testing. So here you can see. So this is the predicted segmentation mask. So we have given the image. That means we have given this image, which means 100.jpg. So 100.jpg means this image. So this is the input image. Sorry, this is 100. So we need to take out the result of segmented outcomes. So here you can see, here we can able to display the original image as well as the predicted mask. So this is what how we can able to do the segmentation using the vision transformer model. Hope you understand that one. So both the things, both the classification as well as the segmentation using vision transformer model. If you have any doubts, you can ask me and you can contact us. So those kind of implementation we can able to help you. Thank you. Thanks for watching us.